Good morning. Myself Prabha, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is Domino Logic from the Unit 2, which is combination logic circuit in the subject of VLSI design. Let us discuss. Yeah, Domino logic is a dynamic CMOS logic style that is widely used in high-speed, high-performance digital circuits such as microprocessor. It combines the benefits of dynamic logic and with some of the robustness of static logic. Dynamic logic uses a clocked pre-charge and evaluation phase to perform logic function. In dynamic logic, the output is either pre-charged to a known state during one phase of the clock and conditionally discharged during the other phase. And here you can see the domino logic structure. Pre-charge phase, the output node is pre-charged to logic 1 by a PMOS transistor controlled by a clock signal. When the clock is low, the PMOS transistor is on and output node is pulled out VDD, which is logic 1. Okay. Evaluation phase. When the clock signal goes high, the pre-charge transistor is turned off and the logic evaluation takes place using an NMOS pull-down network. If the logic conditions are met, the output discharged to ground, which means logic 0. And domino logic. The name domino comes from the cascading nature of logic gates in this design, just like a row of dominoes falling one after the other. The output of one stage of domino logic trigger the next stage, allowing for high-speed sequential logic operation. Each stage can only evaluate once per clock cycle, which ensure that the circuit resistance is glitches at the as the pre-recharge phase reset the output before next evaluation. And components of domino logic is dynamic gate. The dynamic gate consists of pull-up PMOS transistor, which means for pre-charging, and the pull-down NMOS network for evaluation. Inverter, a static CMOS inverter is placed after the dynamic gate to buffer the output and prevent charge sharing or back driving from the next stage. This inverter also ensure that the output stages stable between clock cycles. Here you can see the domino gates follow dynamic stages with inverting static gate. Dynamic static pair is called domino gate, produces monotonic output. Domino optimization. Yeah. Uh, Domino optimization to create domino logic circuits that are fast, power efficient, and robust against noise and process variation. This specific technique used will depend on the design goals and constraints of the particular application. Each domino gate trigger next one like a string of dominoes. Toppling over. Get evaluate sequentially but pre-charge in parallel. Thus, evaluation is more critical than a percentage. Next, dual rail domino. Dual rail domino logic is an extension of standard domino logic that enhance noise immunity, robustness, and reliability by using both the true and complementary signals. This approach, robustness, is particularly useful in high performance digital circuits where noise margin and signal integrity are critical. Some Let I discuss some concept of dual rail domino logic. First one is true and complementary logic. The dual rail domino logic. Every logic signal is represented by two wires, one carrying this true signal, and another wire is carrying the complement of the signal. Dual rail domino gate structure. Each domino logic gate is a dual rail configuration, has two separate evaluation network, one for the true output and another one for the complement. Inherent error detection and improved noise immunity and glitch detection, static power consumption. Dual rail approach can slightly increase dynamic power consumption due to the additional circuitry. Here, some examples of dual rail. True output. The circuit of the true output will have NMOS transistor connected in series corresponding to the AA and BB complementary output. The complementary output will have separate NMOS network that is logically equivalent to the complementary input. Okay. Some of the advantages of domino logic. Domino logic is faster than static CMOS logic because it eliminates the need of complementary PMOS network and reduces capacitive load and reduce transistor count and glitch-free operation. And some of the disadvantages of domino logic is static power consumption, charge sharing, clock dependency, and the application wise high speed arithmetic circuit. We can use the domino logic in high speed arithmetic circuit and processor and high performance digital systems. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.